मैं बोलूँगा मेरे को पता है
भाई मैं तो प्रैक्टिस कर रही हूँ 2 हफ्ते और अभी 5 चैप्टर्स बाकी हैं इसलिए तो पूरे प्रैक्टिस करके आई हूँ कोई ले जाता है तो क्या वो करना है अरे वही मैच out of 20 full marks तो मैं बात पे इतनी देखा तो टॉपिकली टॉपिक कर रहे हैं वो अपने पास कॉपी नहीं कर पाएगा marks in that. Sorry, can I see the mark? 20 or 20? 20 we know. 5 we know.
Where did we stop in the last class? Yeah. Yes. Okay, so I think electrical resistance, right? We just started, or had I finished it? What is the symbol? R. So what is electrical resistance? Last class I think we had discussed it already. It is the obstruction to flow of current. Flow of current. So what causes the obstruction to flow of current? Suppose this is a conductor, right? So the conductor you have lot of positive ions and free electrons, right? Any conductor has to have lot of free electrons for current conducting to take place. So this is how it is. हाँ दोनों बेसिक है ठीक है क्या हो गया सर बस ये होमवर्क थोड़ा करके आए और मैं तो होमवर्क देता नहीं फिर होमवर्क देना शुरू करना पड़ेगा देखो when there is no potential difference applied तब क्या होता है at room temperature these electrons will go in random direction ठीक है and then they collide and after collision change their direction you don't know which direction so when no potential difference is applied the net flow of electron is zero because कुछ left right to left जाते हैं कुछ left to right आते हैं and the net flow is zero. Now when the potential difference is applied then what happens? Now let us say we have a potential difference which is applied like this. Now what will happen? So these electrons will be forced flow in their direction. Okay, so the random movement of electron will be forced into a specific direction. Then too, whenever they encounter the positive stationary charge, they will collide. And because of this collision, its direction will be changed. Let us say after collision, it goes here. But again, because of this negative charge, it will be repelled back. So finally, all of them will be flowing from this end to this end. And the current flow will begin in opposite direction to flow of electron. What is the direction of flow of electron? Right to left. And therefore, conventional current will be left to right. Is it clear? So what I'm trying to say, why is this resistance? This resistance is due to collision of electron with stationary charges and amongst fellow electrons. Right. The resistance is due to the collision of electrons with fellow electrons and stationary positive charges of the conductor. Stationary positive charges of the conductor. Right? So how do we find resistance of a conductor? To find the resistance of the conductor, we need to know the applied potential difference and the current flowing through it. Okay. So what is found is, it is observed that current flowing through the conductor is directly proportional to the applied potential difference. Okay. It is observed that current is directly proportional to the applied potential difference, right? When provided the temperature of conductor remains constant. Only then, right? When the temperature of the conductor remains constant, then we will say that current is directly proportional to applied potential difference. So since R is directly proportional to V, we can also say or E is proportional to I. When there is a direct proportion, we can write either ways. Okay. And therefore, E is equal to constant I. This constant is R. Okay. And therefore, R is equal to V by I. Where R is constant of proportion. Called resistance of the conductor. Right? What does it mean? Whenever we increase the voltage, current increases in direct proportion. That is why V is proportional to I. This expression is called Ohm's law. Right. So we can find resistance from Ohm's law as ratio of applied voltage to current flowing in the conductor. What is the unit of resistance? Unit of resistance is ohm. Its symbol is ohm. So when we will say that the resistance of the conductor is 1 ohm, right? When 1 volt applied across the conductor results in a current of 1 ampere. Okay, that will say that the resistance of the conductor is 1 ohm. Repeat this two words. It is the obstruction to flow of current where in the conductor. The resistance is due to the collision of electrons with electrons. Okay, okay. Okay. Okay.
Yeah, ID was for the next.
Any questions here? Sure? Okay, no resistance. So, what is one resistance then? Yes, blue box, the last blue box. Read it. Read it for the whole class.
The resistance of a conductor is said to be 1 ohm because current of 1 ampere flows through it, then the potential will be controlled with 1 volt.
So mathematically we write it like this. What is 1 ohm resistance? When 1 ampere current flows through the conductor after the application of 1 volt potential difference across it, then we say the resistance of the conductor is 1 ohm. Right? So if this was 1 volt and this was 1 ampere, right? Then we will say that R is equal to. Okay. So what was the symbol of resistance? Anybody remembers? What was symbol of resistance? ठीक है? इसका यूनिट है. तो हर बार हम ऐसा कंडक्टर नहीं बनाएंगे. In the circuit, we will make this diagram. What is the difference between this resistance and this? Huh? This is a fixed resistance. This is a variable resistance. And what about this? This is rheostat. Okay. So there are 3 terminals in rheostat. This is rheostat. ये सब बता चुका हूँ ना पहले. ठीक. Okay. So now the last part of this chapter is we have to study about factors affecting resistance of the conductor. Right? Can I erase the right thing?
Yes.
Why are you fighting with it? If there is no your thing here. Okay, let me erase this. So factors affecting the resistance. Okay. Okay. Of conductor. So first is the length. What will happen if the length of the conductor is increased? Look here. If I increase the length of the conductor, what happens? The path of the electron increases. Yeah? So its collision also will increase. Isn't it? Will it not increase? Because if I stretch this conductor, it will become thin. It will become something like this. Initially, if the conductor was like this, now if I stretch it, it will be, let us say, like this. Okay, half cross section. So the length is doubled. Length is now 2L. This cross section was A. Now it is A by 2. So the width or the passage becomes narrow for the electron to move. ठीक है? तो क्या होगा? रेजिस्टेंस बढ़ेगा या कम होगा? बढ़ जाएगा, है ना? पैसेज अगर ये पतला कर दे तो तुम लोग को भी चलने में तकलीफ हो जाएगी. ठीक है? So with the length of the conductor, resistance increases. So the first thing is resistance is directly proportional to length. Okay, so it increases with increasing resistance of the conductor increases with its length. So that was the first thing. What about second? What about the area of cross section? Cross section area of cross. What is the relation between area of cross section and resistance? Let's say its resistance is R1. This is R2. Which is greater, R1 or R2? How many with R1 greater than R2? What's your take? 5. It's written. Read it carefully. R2 is greater. It's written. You just wrote, right? Length increases, then the resistance increases. Okay, so R2 is greater than R1, right? Now, second, I am asking the area of cross section A. You knew it, right? You just avoided the question. And you are saying yes. What? Okay. Now, what about the next question? Who will answer? She will answer. Yes, you know the answer. It's on the board. I am saying, what happens with the change of area of cross section? What will happen to the resistance?
The cross section is
Increasing. Let us say the cross section increases. What happens to the resistance? Increases. You know? It's like when I increase the passage, movement of the electron will be easy. Okay? And R2 is greater than R1. So when the area of cross section increases, I get R1. So resistance decreases. Okay? So with increase in area of cross section, the resistance of the conductor, what happens? Increases. Right? Oh, decreases. Decreases. There is an inverse relation. Area increases, resistance decreases. Because now this opposition will be less and the passage is wider. So what is the relation here? Therefore, resistance is inversely proportional to area. Then there is a temperature dependence. Temperature dependence. What happens? So now you have to remember that the wire has a lot of stationary positive charges through which the electrons are moving. This flow, right? Whatever. They will collide, change direction, again they will come back. This way. So what happens when the temperature of the conductor rises? When I say effect, all these parameters will increase, and then tell me what is the effect on resistance. Tell me what happens when the temperature of the conductor increases. Yeah. What could be the reason? With the rise of temperature, what happens? You're right. Oh, the kinetic energy is okay, but look at what is given in the diagram. See, what happens is, you know that these are positive charges. They don't leave their position, but they are vibrating. So when the temperature increases, they vibrate vigorously. So will it affect the movement of electron? Like, let us say there is a queue of student, two queues are there. They are standing still. Now I ask you to okay, slip through them. When will it be easy? When they are standing still or when they are dancing like this? So when the conductor is heated, these positive charges start vibrating vigorously, and therefore the passage for the electron to slip through them becomes difficult. Okay, so therefore the resistance will increase, right? Because what is the resistance? Obstruction to the flow of electrons. Anything which causes or aids obstruction will help increase the resistance. So with rise in temperature, the resistance of the conductor increases. Okay, what is the fourth factor? Nature of substance or nature of material of conductor. Of right. So what is nature of material of conductor? Some substances are good conductor of electricity, some are bad. So what's the difference? What is a good conductor? What is a bad conductor?
Good conductor is strong with the electric current passes.
So what is electric current? So therefore it should have more free electrons, right? So like metals are good conductor. That means all metals are basically good conductors. That means they have low resistance. And non-metals are bad conductors. So they will have high resistance. Understood? So nature of material of conductor will also determine what is the resistance, right? So depending on the availability of free electrons, because current is because of flow of electrons, right? In the substance. Right. It will be determined whether substance high or low resistance. Right. More free electrons leads to less resistance. That is good. समझ आ गया? Less or no free electrons. High, very high resistance. That is that. Okay. Good conductors are all metals. So very simple. So depending upon how is the nature of substance, the resistance will be high or low. Even within metals, some metals are good conductors, some are bad. Right? Between iron, copper, and silver, which is the better conductor? Copper is a better conductor with respect to iron, but silver is even better than copper. But then we don't use silver because it is much costly. Do we have table of conductors? You will learn it what it is. 10th standard. 10th standard 11. So the material of the wire, I have written 4. In your book it is given first, right? The nature of material of conductor. Okay. So anybody still has any doubt? Yes. So in terms of this, what about R and T relation? R is directly proportional to temperature. Temperature will rise, R also will rise. Temperature comes down, R also rises. So this chapter is over. अच्छा go ahead, yeah. Okay, so we'll finish that unit and then we will do the numericals. Yes, we've already done it heat and energy over there. Same thing.
Yes.
Okay. So what you do is just read it 5 minutes, just read it and ask if you have any doubts. We have covered it. Okay, so it's exactly the same. Take 5 minutes to read through it, all of it. Which line? This one. We didn't say to switch off the AC, right? AC again. Okay, yes. Okay. Efficiency, use of energy. Let me know once you are done reading. We will discuss it. If you have any clarity required. बढ़िया कौन सा पॉइंट पढ़ रहे हो उठी नहीं है पीछे बहुत बढ़िया बहुत कुछ सर सेम हो अभी बना रहा हूँ कुछ अलग नहीं है ना कंटेंट्स आर सेम है प्राइस अलग है दैट्स आई फील राइट प्राइवेट गो so So what is the first step you will take to make efficient use of energy? You'll take steps to use it wisely. Isn't it? So first thing you will do is if it is not needed, you switch off. करते हो घर में? ठीक है? So first thing to use energy available resource efficiently is to use it wisely. So that's so. And the second thing is by doing proper insulation. What is the meaning of insulation? So if you want to achieve cooling, right? ऐसा नहीं होना चाहिए you're cooling inside and more heat is outside. So windows should be closed, right? And walls should be bad conductor of heat, right? Otherwise, this AC will die. It is cooling and still the air inside is becoming warm. Okay, so that is achieved through proper insulation. Okay, so that was point number one, right? So it works both ways. In cold countries, you are trying to heat a room. So the same air conditioner would work on heating mode. You switch the mode, it acts as heater, right? In car, you must have seen, right? It has a cooling and a heating mode. License लिया क्या? Smile और magnetic thing. कार का नाम सुन रहे. Okay. Second point is we should use appliances which consume less energy. Okay. So earlier we used to use, I don't know if in your lifetime have you used bulbs with filament?
Yes.
Have you? Use किया है filament वाला bulb?
दिवाली में वही लगाया था।
वो तो चलो बहुत मतलब ये देखो ये वाले बल्ब हम फिलामेंट वाले यूज नहीं करते ना हमारे चाइल्डहुड में ये फिलामेंट वाले बल्ब यूज करते थे उसका इलेक्ट्रिसिटी ज्यादा जाता है और ल्यूमिनेंस कम है ल्यूमिनेंस मींस द विजिबिलिटी लाइट वो पीली पीली येलो लाइट आती थी और पूरा गर्म हो जाता है so lot of electrical energy is converted into heat and less light less luminance okay so that is not efficient so what has been done is now all the lights are replaced with LED so this is a LED bulb so it consumes very little power almost 1/10 of what used to be like used by 100 watt bulb. Now this is like how many watts? Less than 10 watt. This might be what? 10 or 12 watts. So हमारा 1/10 हो गया power consumption. So that way. And so LED has drastically helped in reducing our electricity bills. So all the street lights that you see, bright lights, okay, luminance is more and power consumption is less. So it's a two-way advantage, right? So that's the benefit of better technology. So what is LED? It is light emitting diodes. So light emitting diodes. You will learn it in your 12th standard. If you continue to study science, right? And before LED, we used to use CFLs. So compact fluorescent lights. So this tube light, is it a fluorescent or LED? LED. Earlier we used to have fluorescent light. देखा है? Difference पता है? बता सकते हो? So when you switch on fluorescent light, it doesn't get on instantly. It flickers. Okay, then the whole tube becomes like uniform. So that is fluorescent, right? But this is instantaneous. Plus there is no filament. तो fuse नहीं होता. Fluorescent में क्या होता है? Electrode होता है. तो they emit electrons. And then there is a gas filled in the tube. So they excite the gas. Then gas radiates visible light. Okay. So you will study about cathode rays, discharge tube. Have you studied about it? Cathode rays and discharge tube in chemistry? Cathode rays के बारे में सुना है? वो जो फ्लोरेसेंट वही वाला चीज को इम्प्रोवाइज करके ट्यूबलाइट बना दिया. But now we don't use it. Why? Because the fluorescent substance used is toxic. It's not good for environment. So is CFL. So we had compact fluorescent lights. पहले तुमने देखा था कि ऐसा टाइप का ऐसे वाले बल्ब यूज होते थे शॉप्स पे. So these are compact fluorescent light. वो आँख में भी बहुत ज्यादा लगता है. So it has inside it mercury, which is not good for environment. So bulb एक बार खराब हो गया तो it is disposed in the garbage. And animals eat. It also may contaminate water table. So not good for us also, right? So although it gives you less electricity consumption, but it also has a trade-off. Not good for environment. But now this is the best we have, LED. Right? So this is how we can bring in efficiency by choosing right type of lighting equipments. Fifth point is nowadays we have appliances with Energy Star rating. Like AC comes with 4 green star, 5 green star. So higher the number of star, more money you shell out at the time of purchase. But then less bill, less electricity bill over long usage. So you recover that cost. So initially you pay high price, but over long usage, everybody benefits. Okay? Because it consumes less power and it is more environment friendly, right? So efficient use of energy means two things. One is to use it wisely. Other is to also, it is less taxing on the environment. Okay. So that's what we choose. Sixth, so when the building is designed, right, it has to be the location of the building and its surrounding and design should be such that we should use as far as possible the natural lighting. So we'll have to use, so like in walls, we have now white roofs, transparent or translucent, right? So the daylight, during daylight, we don't use that much of lighting. So we have to think of a way to basically use it at home also, right? I mean, otherwise, if it is hotel, etc., or offices, even in daytime, we switch on all the lights. Like here itself, beauty. If we come in the morning, the lights will be on. That's not good practice. Okay. Okay. Seventh point: use of advanced boilers and furnaces in industry. Now, in industry, like we have ores, right? So if we are trying to extract iron, we have to actually melt ores, then do the filtering. Okay. So we use very high power consuming boilers or furnaces, right? Garment we use what? The gas chula, which is very small. But in industry you have huge, humongous. Right? So it consumes a lot of energy. So we have to basically in industry upgrade to advanced boiling and furnaces, boiler systems and furnaces, which consumes less power, so that it is using the optimal energy and also it is less polluting, right? So all the points till 6 were like by domestic application, and 7, 8, and all your Seventh is industrial application. Then you have eighth is also if we use vehicles with better energy efficiency. Again, will be good for environment and it will drain the energy resources less. And I see the smile on your face again. So, जल्दी बाइक या कार की लाइसेंस okay. ठीक है. So I think this we had covered earlier also. Then there is an international agency, right? International Energy Agency, IEA. What this energy says is, it has done a research, and it says by 2050, which is like another how many years? 20, 27, 28 years. 28 years. 28 years. The energy need will be reduced by 50%. If we choose the appliances wisely, right? If we use latest appliances, the energy requirement of the entire globe will go down. When the energy requirements go down, the carbon production also will be reduced to half. So we'll benefit both ways. Now, I don't know whether it is only for business or it is actually going to help us. Only time will tell, right? But that's what this report says. It's not 50 by 1/3, right? So it would reduce the world's energy need in 2050 by 1/3. 1/3 is roughly 30%. 33%. All right. Now, what are the social initiatives we can take to promote efficient use of energy? So we can hold a lot of seminars, public awareness. उसके लिए क्या कर सकते हैं? What steps can we take? So efforts to develop energy efficient machines to let the scientists do it for us. And what else? The technologies which can reduce energy expenditure and renewable environment. The same thing. So create awareness amongst people. Encourage them. That's what I'm doing. So you will sign before leaving today on one page and tell me the evening, right? Sir, we will do what on we discussed. Okay. And through not only government side, non-governmental organizations. So it has to be public, private participation, participation by every stakeholder to achieve what this chapter is trying to tell you. So are you going to sign a treaty today? With yourself. Don't cheat yourself. You like cheating? Yes. Don't cheat. You, I was sure. Chalo. So is this chapter over now? Anybody has any question in this chapter? If not, we will do numericals. Right? Numerical to ज़्यादा है ही नहीं chapter. हाँ? So I think you have numerical only 9B. 9A numericals we completed, right? So we did it. Okay. Let's do 9. So who will do? Don't cheat yourself, huh? Because you cannot run away from yourself. Can you run away from yourself? No, you promise yourself. What did you promise? Yes. Numerical 1, numerical 2. How many numerical? 4. Four, 5, 6, 7, 8, 9, 10, 11, 12. Right. So this is how we'll go. Okay, start with you. So like this, 1, 2, 3, 4, 5, 6, 7, right? In this sequence, and then after that. So let me give you a number. You are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Are you remember what is your number? So we'll make there are 4 numericals, right? So this group will do question mark. Okay, who is 1, who is 5, who is 9? Raise your hands. 1. Okay, you are doing question 1. So question 1 allocated. You can discuss among yourself, do it. 2, 6, and 2, question 2. Do it, and once you're ready, come on board. नंबर याद है सबको अपना? This team is ready. This is team 1. This team is ready. Team 3 ready. Who are in 3? 3 में कौन है? 3, 7, 11. Who is 3, 7? 3, 7, 11. Come on, step out. First question first. Team number gets the question. Yeah, वहाँ पे ही कर दो चलेगा. Just write down the mental thing. Where are the other members? All of them have to come forward. You are part of 3. No, 3. Team number 3, come out. 3, 7, and 11. Where is 3? Come out. Yeah. So you did not discuss among you. I said you have to discuss with your member. When all are ready, let's go. Who is ready? Team number? Team 1. Raise your hand, team 1. Team 1. This is not a good team work. You have to speak to your team members. Which team is ready? 1. Listen, your other team member is coming. You can discuss with her. Huh? 1, 2, and 3, right? Discuss among yourself. All 3. The first thing you should have done is stand with your team. All teams are. Which team? Stand up. Team 2 stand up. Only team 2 come forward. Team 2 come forward. Meanwhile, other members help their members. Team 2, tell me your name. Introduce all the team members. Manasvi, Ranveer, and go ahead. Write your question number and solve it. Manasvi, who is going to write it on board? Who is going to help? Manasvi will write, okay. Ranveer and Akshat will help. Akshat. Where is my book? 24. You can use this marker. These are better. Duster is. Correct. Correct. No. Two better. Question two में हाँ एम्पियर ही है तो सही तो है B by R करेक्ट है क्या निकालना है तुम्हें I निकालना है ना हाँ तो I लिखो ना R की जगह पे और B by R हो जाएगा I is equal to B by R तो निकालना क्या बाद में सब्स्टिट्यूट करना है then B is equal to that by 24 1 by 2 1 by 2 which is 0.5 एम्पियर direct पर लिखो कैपिटल okay ठीक है question 2 is solved right sit down which came next एक ही question करने study with the next question which team team 1 come on team 3 आ गई है ठीक है so just wait let keep playing team 3 question 2 is done on the board those who want to write can write two question burn loss current so current is given voltage is given all Ohm's law questions right all questions are
स्कोर क्या है
कैसे लिखोगे जरा ठीक से लिखो ठीक है करेक्ट एक टू नीचे दिख रहा है दोनों ऊपर लिखो ना 10 वाला 2 के ऊपर लिखो या उसके साइड में यूज ब्लैक मार्कर 2 is ठीक है 4 so question number 3 and 4 3 and 2 is done team 1 come forward is that thing working is that thing working is it time so you want to do now or after the break we have a after the break shall we take the break after the break oh yeah just fix that रिमोट से भाई क्या हाँ किसी ने वो टच कर दिया बैक करो ठीक है we'll resume and we'll also start magnetism
Yeah.
Game one. So you can erase B and 2. Which is team 4? Okay. Team 1 you already right? Please come. Not 2. All member, all team 1. All team 1. If you want, you can erase left side just to make space. Do it. Okay. What is this question about? What is this question about?
Find
So this question is about what you have to find the potential difference. So perfect. So potential difference is this the unit of potential difference? Joules per coulomb or volt. Okay. So this is 6 volt. If you're writing joule, you have to write joule per coulomb. Okay. And joule per coulomb is called volt. Okay. Is it clear? So team 4. Use black marker. Everybody is using red color. You all like red color? क्या रेड कलर अच्छा मैंने बोला ब्लैक नहीं तो okay I forgot narrate your name. What's your name?
Chapel.
Shardul
Yeah.
and Shardul is doing the hard work. These two girls.
No, they can't.
Okay. Who did the question? And what did Shardul do?
She was also
Okay. Question number
one.
one is already done. What's your name? 4. So what is given? First write the given data. Current is equal to 2. Write down. I is equal to 0.2 ampere.
0.2
Ampere.
and
Then what is given?
R
R is equal to 15 ohm.
50
Oh, then what do you find the potential difference?
potential difference will
Equal
be
to what is Ohm's law? Ri.
ion.
Anything. So this is equal to
V will be equal
V
to
is looking like an under root sign. V properly. Again,
0.2 into 15,
yes, which is 3.
which will be 3.
0. What is the V? Correct.
So,
All right. So all of you have done a good job. Huh? Clap for yourself. Yeah? You don't like yourself? Everybody clap for you. So good team spirit. Everybody participated, and I hope everybody has understood. Okay? You did not understand?
Yeah.
Why did you laugh? Okay. So is this chapter okay? Any concept still you want me to explain you with? Or else I'll move on to magnetism. Short magnetism. Oh, done. Yeah, we have reached on to the last topic or last chapter. Have you studied about magnets in previous grades?
Yes.
So you're already familiar about some magnetic properties, right? So this is chapter number
10.
magnetism. So what is a magnet? What is a magnet? What is going on? क्या चल रहा है? Huh? What is a magnet? Metals or iron, right? So it has two properties. Calm down, girls, calm down. Your life is very important for us. So what is magnet? It has an attractive property, right? It has attractive property. So first let us understand. So what is that attractive property? That is, it attracts. Yes. Attracts iron pieces. So metals means, will it attract copper? No, it is non-magnetic. So it will attract magnetic substances or so iron or magnetic substances. Okay. What is the other property of a magnet? It has directive property. What is directive property? Anybody remembers? So when it is suspended freely, it will rest in north-south position, geographic north-south position of Earth, right? So when suspended, it rests in geographic north-south direction. This you are familiar, right? So if you suspend a magnet, let us say this is north, this is south, this is east, west. Okay. When you suspend the magnet, so it will okay. And the end which is pointing towards north is called north pole. And which is pointing towards south is called south pole. So what is the other property of the magnet? Magnet has two poles, north and south. Okay. So which is north? So this the end which is pointing in the north direction of Earth, that is north pole. Then what is the other property? When two magnets are brought closer, right? Then like poles repel each other. And unlike poles attract each other. Probably these properties you have learned. Have you?
Yes.
Good. Okay, so any magnet would have at least these properties. Now question. Why a magnet settles in north-south direction when it is suspended?
Magnetic field attracts it.
Yes, because magnet would always try to align itself in the magnetic field of other magnet. So what is this other magnet now? Earth. So what is Earth's magnetic field? Now see, if this is Earth, right? It acts as a giant magnet. So this is actually geographic north. And this is geographic south. North pole and south pole of the geography. But the magnetic, this end therefore might be acting as a south pole. This is magnetic south of Earth. And this is magnetic north of. Okay, one more thing I have to give you here as a property of a magnet. See, whenever you have a magnet, let us say this is a bar magnet, right? Now you know that magnet has north and south pole. So its magnetic field lines, they come out of north pole and enter at south pole, outside the magnet, right? And inside the magnet, it travels from south to north pole. That means it makes a loop. So magnetic field lines are closed loop, right? So here also. Right? And there are so many field lines. So what is it? This is the magnetic field line. Now what is a magnetic field line? It is the visual representation of magnetic field in the region around any magnet. And what is magnetic field? So field line represents magnetic field. But what is magnetic field? So it is the region around the magnet in which the magnetic compass, okay, rests in direction other than geographic north-south. The magnetic compass will always align itself with the stronger magnetic field. Earth's magnetic field is very weak. So everywhere there is Earth's magnetic field. So if I keep a magnetic compass here, it will show me north-south direction. But if I bring any bar magnet close to magnetic compass, let's say this is the magnet. Now this magnetic compass will not show north-south. It will be in the magnetic field of this magnet. Okay? So how do we define magnetic field? Magnetic field is, it is the region around the magnet where the magnetic compass rests in direction other than north-south of Earth, other than geographic north-south, other than north-south direction. Okay? So this is how we made these magnetic field lines. How did we make? How do we know that the field line comes out of North Pole? Because what we did was, okay, at this point we kept the magnetic compass, so it pointed in this direction away. Okay. So when we keep a magnetic compass near the magnet, it pointed in this direction. Then we mark these 2 points, this and this. Now what we did, we kept the magnetic compass at this point. Then wherever it was showing, we marked those 2 points. Then we kept the magnetic compass over here. Then it showed in this point. And so on and so forth. When we repeat it, when we join the dot, we get a closed. This is how we know that the magnetic field lines are like this, because magnetic compass will always align in the direction of magnetic field. Clear? How we make the magnetic field lines for any magnet? And then we realize that these field lines are crowded near the poles. And as you go away, it becomes spread out. So wherever the magnetic field is crowded, its strength is more than in the location where it is spread out. I will cover this again. This is the concept that you have to get to understand this chapter. That's why I thought I'll cover it in lately. We'll repeat all of this again. So the question was, why the magnet always points in north-south direction? So if I keep the magnet here, if I hang it over here, it will show in this direction, which is pointing in the north. So which means here it should be north. That's why north of compass is repelled away, right? And this must be south. So north is pointing towards south. Okay, that's why this is magnetic south of Earth, and this is magnetic north of Earth, right? And there is some deviation from the actual geographic north. They are not exactly like, they don't coincide with each other. Got it? So when the compass reaches here, so how it will become vertical. Out here it will be vertical like this. Okay. And here it will be, so here it is vertical or horizontal? It is the angle which makes with the surface of Earth. It is 90, right? What is the angle here with the surface? 0. It's parallel to the surface. Okay. So here it will be like this. So every time it's like this. Okay. So when you join where the magnetic compass is parallel, this line is called magnetic equator. Right? So on the earth, the field is something like this. That is why here the needle becomes vertical, whereas here it is aligned. Okay, so it is always aligned in the direction of the field. This is also how the field is. Got it? So it comes from the south, geographic south pole of Earth and enters here. So that means when the field line are entering, this must be Earth's south pole. You got it? So too many things I have told you in one slide. So take some time to absorb all this and ask me if there is any clarification required. So this, what you see here is Earth. So what is geographic equator? Geographic equator is the line, this surface which cuts the Earth in upper hemisphere and lower hemisphere. That is your equator, right? So this is equator plane. So equator plane cuts the Earth into two parts, upper hemisphere and lower hemisphere. The magnetic equator likewise cuts the magnet into two parts, right? But it is slightly tilted. So this dotted line is magnetic equator. Is that clear? Any questions here? We have not yet started the chapter. It is just the introduction. Okay. All of you understood at least this part? Yes or no? Okay. What's his name? Who is he? Rajveer, right? My bad. So Rajveer, any question? Yes, no. कुछ unsatisfactory जैसा लग रहा है. कुछ और बोलो. कुछ और बोलो. इसमें से सब समझ आ गया तुमको. What is magnetic field? Region around any magnet. Where
magnetic compass points in the north-south direction.
Rest in the direction other than north-south. देखा पकड़ लिया. ठीक है ना? नॉर्थ साउथ में कब रहता है? कहीं पे भी जहां मैग्नेट नहीं है, क्योंकि अर्थ की मैग्नेट तो एवरीवेयर इट इज. बट इफ वी ब्रिंग एनी मैग्नेट, तब अब मैग्नेट दूर ले जाएंगे तो नॉर्थ साउथ जा रहा है. जैसे ही मैग्नेट लाएंगे मैग्नेट की फील्ड में हो जाएगी. समझ आया? So that is magnetic field. So this is the region of influence around any magnet where the magnetic compass rests in direction other than north south. Okay. Okay. So far so good. Can I clear the board? Anybody writing? Okay. So next is we have to learn about magnetic induction. That's the first one. Right? That's the first topic, right? Magnetic induction. Now, what is magnetic induction? देखो, ये एक जादू है. ठीक है? It's magic. So suppose you have a magnet. ठीक है? What do you have? You have a magnet. Now you bring any magnetic substance near it or touch it. If it is a magnetic substance, right? Let us say bring one metallic or iron bar near it. This is iron bar. This is not a magnet. Okay, what is it? Iron bar. The scene is we have an iron bar and we have some magnetic substance का powder, मतलब iron fillings. ठीक है? So let's say this is iron filings. What is iron filings? If you file or rub any iron, this iron powder will be there. Okay. Now what we are doing is I brought a magnet close to this. Then what we see is all this iron bar goes and sticks to this iron bar. Meaning, when I bring a magnet near any magnetic substance, that magnetic substance acquire magnetic behavior. This itself starts acting as a magnet. So bringing of magnet near a magnetic substance makes the magnetic substance a magnet temporarily. That's why we call it induced magnet. Induced or magnetic induction. Magnetism is induced here. Okay, but that is temporary. Till when? Now when we take it away, then again these filings drop down. Okay, then what must have happened? For it to become HR. The other thing is also when I bring iron bar, then it is attracting. Okay, this magnet is attracting this iron bar towards itself. But what did we learn? Opposite poles are attracted. That means when this iron bar became magnet, then it must have developed the opposite pole to this pole. And this end must have become north pole. Okay? So how the magnetism is induced? This side becomes opposite pole of this polarity. Okay? And this end is the same polarity. Okay? So this is the phenomena of magnetic induction. So it is the phenomena of temporary just check this in temporary magnetism induced in a magnetic substance when it is brought near a magnet or is placed in contact with it. So yeah, either you bring it close or touch the magnet, then it will have magnetic behavior. Right? The magnetic substance. Okay. You would also observe it. So if you had some nails, right? A heap of nails, right? So those nails also will become magnets. So this will become south pole and this end will become north pole. Right? So if there is a heap of nail, all the nails will go on connecting with it. So if I've kept it on a table, so will it like go on forever? Because some force, the magnetic force is holding it, right? So how many nails will be held? 2. And why do you think so? Why not 3 or 4? इतना कैसे हंस रहा है? तू बता कितना हैंग करेगा?
कितना भी आएगा
कितना भी ऐसे ही कहते को हैंग कर दूंगा
करना बहुत ज्यादा वजन नहीं आएगा
हाँ सो द मैग्नेटिक इस मैग्नेट का एक स्ट्रेंथ होगा ना मैग्नेटिक फोर्स दैट फोर्स शुड नॉट बी इक्वल टू द वेट ऑफ ऑल द नेल्स पुट टुगेदर weight is Newton right and that is equal to force so magnet समझो 10 न्यूटन लगा रहा है 10 न्यूटन बहुत ज्यादा होगा समझो मैग्नेट इज exerting 1 न्यूटन ओके तो 1 न्यूटन वेट का जो नेल है that will be stuck here nail will have mass so mg so whatever mass is equal to mass into gravity is equal to 1 Newton, that many nails will be stuck. Beyond that, it will break. ठीक? हाँ. तो अगर ये मैग्नेट दूर करूंगा तो फिर से ये गिर जाएगा. So what is happening? So induction, magnetic induction precedes attraction. Why a magnet attracts magnetic substance? Because it makes them magnet of opposite polarity. इसलिए वो attract करता है. Got it? So magnetic induction पहले magnetic induction होगा फिर attraction होगा हमेशा. This is how it works. समझ आ गया सबको? So now read the blue boxes and induced magnetism is temporary. These are the key things that you must understand. ठीक है? To read all the blue boxes, whatever I have explained, your concept will be revised. All 3 blue boxes you read. Okay. Read till here. Okay. 3 blue boxes on page 201 and 1 blue box on page 202. Then I want somebody to explain me the diagram 10.4. Also. What happened? What is that scheme? No. The last blue box, right? You'll understand again. The first three blue box, I think no issues, right? What about the last one? Paper. So are you clear with what is magnetic field and what is magnetic field lines? First, you should understand this. Magnetic field, I already told you what it is, right? What is magnetic field lines? The magnetic field lines are visual representation of magnetic field. Are visual representation of magnetic field, right? Around a magnet in the form of closed curves or loops. Okay, these are the magnetic field lines. Okay, so what are the magnetic field lines? Therefore, it comes out of North Pole. This is North. Yes. That's why this is North. This is South. So now we will learn properties of these field lines. So once you understand the properties of the field lines, क्या हुआ? डरे डरे से क्यों हंस रहे हो तुम लोग? हंस रहे हो लेकिन खुल के नहीं हंस रहे, क्या बात है? हाँ हाँ कर रहा हूँ एक्चुअली. So what are you saying? The field lines are crowded near the poles, right? Are the field lines crowded near the poles? Are they cutting each other? No. Are they in the same direction at every point? No. No. So these are forming closed curves everywhere. ये भी बड़ा सा curve बनाएगा. We are not showing. This also will make a big curve, right? It is not like just one line. Now see, what is the field direction at every point? Here it is in this direction. So wherever is the tangent, at any point the field is in the direction of tangent at that point. Okay. So the question is, what is the field direction at any point of the magnetic field curve? It is at a tangent at that point. So every point it is changing, right? Here it is in this direction. Got it? What is the other learning? It comes out of the North Pole and enters into South Pole, outside the magnet. and inside the magnet from south pole to north pole. So these properties should be by heart, right? So properties of magnetic field lines. Magnetic field lines. First, right? Emerges out of north pole enters inside, enters into north pole. Right? Where outside the magnet. And from south pole to north pole inside the magnet. Okay, is this point understood very well? Because that is how it will complete the loop. Okay. Next. Its direction at any point is along the tangent at that point. On the magnetic field line curve. ठीक है? So direction tangent का कहाँ पे होगा? It can be this side also and that side also. So which side you will take? You will take north to south होना चाहिए, that direction, because the line can have two directions. So what will determine the direction? It should be north to south outside, and inside it should be south to north. That's how. This is the direction. Clear? How will determine the direction? Next. So magnetic field is a vector quantity. You're familiar with scalar and vector quantity?
Yes.
So magnetic field is a vector quantity, which means it has both magnitude and direction at every point, right? That is, therefore, it has magnitude and well-defined direction or unique direction at every point. Unique direction at every point. Okay. Fourth, magnetic field lines do not intersect each other. Question is why? Is this allowed? Can two magnetic field lines intersect each other? No. Why?
Because it would mean different magnetic.
Huh?
It would mean different magnetic field for the man.
So that way. So there is no different magnet. I'm saying magnetic field lines of the same magnet. Can they cut each other? No. Why? Read point 3. So this is not allowed.
Because it has unique direction.
Unique direction. So here is the direction unique at this point of intersection. Because at this point you can have a tangent in this direction also. In this direction also. So which tangent to take? Is the direction unique? No. So that's why it's not allowed. Again, best to have a unique direction. At intersection, the direction is not unique because there are two tangents there. Again? Okay. Next. Wherever the field lines are crowded, it means more magnetic field strength. More magnetic field strength. Okay, so if you see the diagram where the magnet has maximum field strength, therefore, a magnet has maximum field strength. Here are the poles. Next is uniform and non-uniform field lines. What are uniform field lines? Equally spaced magnetic field lines, like parallel lines. Huh? This is an example of uniform field lines. Right. Equidistant parallel field lines in the same direction. So in the magnet, where are the field lines parallel?
Outer lines.
Are they parallel? Oh my God! Here's the definition of parallel.
Inside the.
Inside the yes. You see, inside the magnet, the lines are like I have drawn with free hand, but if you see in the book, so it's not so. So inside the magnet, it is always uniform. Okay. And where is it non-uniform? Everywhere else. Non-uniform, right? Outside. Then seventh is these field lines are like stretched rubber plastic. These field lines. What is the conjugates? Behave like stressed elastic rubber strings. Stressed elastic rubber. What's the joke? Not share it. So these field lines behave like stressed elastic rubber strings. So what happens to rubber string when you stretch it? Becomes thinner in the middle, right? So that's how they are. So like when they travel together, they will become thinner. Like they will just repair each other. So it will become thinner. When somebody stretches you hard, maybe.
So can you switch on?
I just taught you efficient use of energy. That's for passing the exam. What's up, you should also change it was the same air we are exhaling carbon and other exhaust. Speeds change air. These ACs are like just circulating the inside air inside. There's no provision for fresh air coming inside. Ventilation. Just violated the principle of efficient use of energy. Contract broken. So don't expect by 2050 our power consumption will go up by 1 power. Not going to happen. Okay. All the points understood. This is the crux, and it is going to stay with you. Till we are going to study about magnetism, these things will be clear. Now we know this, so I wanted you to explain this diagram. What is this diagram? Take time to read this and see if it makes sense to you. So there are the iron filings, sprinkled iron filings. Suppose you have a plain glass sheet and you have spread iron filings uniformly, right? Now you brought a magnet below that glass sheet. Gently tap the glass plate. So what happens? So each iron particle becomes a small magnet, right? So magnetism is induced in those iron filings. So they will align. Each one of them will act like a magnetic force. So they are aligning in the direction of magnetic field. To see how is the magnetic field? It is like this only, right? And from the inner ones, they are obeying this. What about the faraway particles? They are aligned according to Earth's magnetic field. That's why you see two different patterns. One due to local magnet. So where the local magnetic field strength is strong, so it is strong near the magnet and near its pole. So you see the behavior, right? It is resembling these magnetic field lines of the magnet. But away from it, it is along the Earth's magnetic field. Understood? Okay. But since they were iron filings, that's why they are not continuous curve. Magnetic field lines are closed continuous curve. So you somewhere you have to fit in closed continuous curve, right? They are closed continuous curve. इसी में लिख लो. एक line add करो. Magnetic field lines are closed continuous curve. We have written here, right? Closed, वहाँ पे just write continuous curves. ठीक है? So I think enough teaching for today. You still have some 5 minutes. Okay, so read through magnetic field of Earth. I have already taught you, right? Just read yourself. In the next class, I think I'll go for it. Yes. Then what is remaining is only the neutral points and electromagnet and its uses. Maybe one more lecture will come. Bye bye. Not for sure. So don't worry, even though the lectures are completed, but we will still meet whenever you have doubt or when you have test and okay? So on demand we will still meet. But I don't know whether it will be physical or online, so you can demand the place. You can place the demand accordingly. Not physical, then it will be physical otherwise. So the formal course instruction will finish in the next class. So 5 minutes to self-review. I'll turn the camera. Who was that? Okay. So any doubt from here, discuss today, anything, and whatever you are reading, you can ask. So what do you Careers are very good, fully good in all tracks. Not that you do science or grade and science or not grade. Just that what you like. Whatever interest you provide that. So it's nothing like if it is not like science, then there was no something in life. You should only know what you like, and that is the toughest challenge. Okay. The earlier you know what you like, your life is set. Like he, of course, doesn't like to study, right? Huh? क्या पढ़ना वढ़ना ठीक लगता है नहीं honestly किसे ठीक लगता है यार पढ़ना I want to do it live in society live in society Blue is any society now they listen. Figure out what you like. But interest may change later on also. This is that for the day. The time. Time हो गया.
शार्दुल को बिल्कुल तेजी करने की कोशिश करेगा ऐसे लेडी basically. The right of which podcast.